Next section, we're going to review factoring trinomials. And the main difference is whether or not we have a leading coefficient or just a coefficient of 1. Now, the main idea is that we want to find a pair of numbers whose product is C, but also that add up to the value of B within our standard form. Our calculator can help us find these ordered pairs. There's a little trick on the TI-84, where if we go to our graphing utility, we can type in the value of C. For our first example, the value of C is negative 15, and then divide by x. And this gives us a rational equation, but more importantly, if we press second and then graph to open up the table, it gives us all the factor pairs that multiply to give us our value of negative 15. Now all we have to do is go down the list and find a row that gives us a sum of our B value, which in this case is negative 2. So we scroll down the list and we see that this row, 3 and negative 5, give us the value of negative 2. So we're trying to find a product of negative 15 and a sum of negative 2, and that is the numbers 3 and negative 5. Now there's a shortcut when we have a leading coefficient of 1, but I'm going to show you the full process so that we have something that we can fall back on even as our trinomials get a little more complicated. So what we're doing with these two numbers is we are rewriting the middle term to be the sum or difference of both of these. So we have x squared plus 3x minus 5x minus 15. So these two polynomials are equivalent. We've just rewritten this middle term into these two. And then we factor by grouping. First term and second term. Now our little shortcut is that notice how the constants in our binomial match up exactly with the two values from our product and sum. So as long as our leading coefficient is a 1, you can go straight to this step. You don't need to factor by grouping. But if you're ever stuck, especially with a trinomial that has more than one variable in it, you can always revert back to factor by grouping in order to get the correct factors. So we take a look at B. We want to find a product of negative 35 and a sum of 2. So we can look at our factor pairs and scroll down our list and see that 7 and negative 5 give us what we need. So using our shortcut, our two binomials will be y plus 7 and y minus 5. Now C, this is one of those examples that again is a little bit more complicated. We can apply the shortcut, but we have to be careful because we have some a's. And we have an a squared. We're still looking at product and sum. Product of negative 16, sum of 6. And so we can look at our chart and see what two numbers give us that sum. So we scroll down, 8 and negative 2. So let's go ahead and do factor by grouping. This one's a little bit more complex. So again, I took 6AP and I rewrote it as these two terms, 8AP and negative 2AP. We can factor by grouping. And we see that we get our factors. 2A and again, it does indeed follow the pattern of our shortcut with the added addition of the a variable in each of the second terms. And like we discussed in an earlier lesson, always check for a greatest common factor. Here we have a GCF of 16y. So when we factor that out, y squared minus 2y minus 3. Then again, we can look for a product of negative 3 and a sum of negative 2. That's negative 3 and 1. So 16y, y minus 3, y plus 1.